So in the last lecture, we have seen the numericals, okay, in the kinetics of particles unit. Now we are going to continue it further. We have seen the numericals of the connected bodies. When two blocks, connected bodies are on the horizontal plane, as well as when the two blocks are on the inclined plane. That type of numerical we have seen. Now we will see the numerical of rotation about the centroidal axis. Okay, some Pulley's problem are there, so 2-3 problems of that type also we will see. Now the next numerical, two bodies weighing 300 Newton, two bodies weighing 300 Newton and 450 Newton are hanged to the end of rope, passing over an ideal pulley. Passing over an ideal pulley, as shown in figure. As shown in figure. Okay. Comma. With what acceleration? The heavier body will come down and what is the tension in the string? And what is the tension in the string? So we will draw the diagram. Now this is a pulley. Now the rope is there. The rope is passed over the pulley. Okay. So the two weights are attached to this pulley. So those weights are, here is one weight and second weight. So the two weights are 300 Newton and 450 Newton. Okay. So what they have asked us? They have asked us that with what acceleration the heavier body will come down. So naturally, which is having more weight, it will come down. Heavier will come down. And what is the tension in the string? And also we need to find out what is the tension in the string. Okay. So if you see here, the motion, see, this is the direction of motion. This weight will come down. Okay, and this weight will move up because this is heavier. So this is our direction of motion. This is the direction of motion. Also, there will be tension in the string. So with respect to this weight, arrow must be away. So this is the arrow which is showing tension. Okay. Here also tension will be there. Tension is there in the string. Arrow should be away for the tension. Now we need to find out what is the acceleration and tension in the string. So first of all, we will consider the free body diagram of this 450 Newton block. So here I will write consider free body diagram of 450 Newton block. Now if I consider the free body diagram, then here see this is a block. This is a block of 450 Newton. Here is the centroid of this block. From the centroid, weight will act vertically downwards. So this is the weight. So this weight is 450 Newton. Okay. Then this tension in the string is there. This is the tension in the string. This is the tension in the string. Okay. So that we will show. So here it is tension in the string T. T is the tension in the string. Now where is the motion? So the motion of the body, motion is like this. This is the direction of the motion. This is the direction of the motion. This body will come down. So if the motion is downward, then what is the direction of inertia force? Inertia force will be in opposite direction to the motion. So this is the direction of inertia force, MA, inertia force. Okay. So now we need to solve this numerical. So first of all, we will apply summation Fy equal to 0. First, we will apply summation Fy equal to 0. Now if I apply summation Fy equal to 0, then it is T minus 450 plus MA is equal to 0. So put the value. So T plus this 450 we will transfer to that side. M is what? Weight is given. Weight is 450. So weight divided by G. Weight divided by 9.81. This will give you the mass. Into acceleration, we don't know. It is as it is, which is equal to 450. Okay. Now this will be T plus 45.87A is equal to 450. This is equation number 1. Please check the values. This is equation number 1. Similarly, when we solve for 300 Newton block, by the same way, we will get another equation. And then we can solve those two equations. So here, now consider the free body diagram. Consider free body diagram of 300 Newton block. 300 Newton block or weight, whatever you want to say, you can. So now this is the 300 Newton block. Here somewhere centroid is there. Now weight is acting vertically downwards. Here is the tension in the string. This is T. Weight is 300 Newton. And the direction of motion of this block is upward. So this is the direction of the motion. This is the direction of the motion. So inertia force will be in which direction? Inertia force is
downward direction.
Downward direction, opposite to the direction of the motion. Inertia force आणि frictional force हे नेहमी तुमच्या ह्याच्या डायरेक्शनला अपोजिट येणार मोशनच्या डायरेक्शनला. So now here again apply summation Fy equal to 0. So T is moving up, so plus 300 is downward, minus 300 minus MA is equal to 0. So T minus M is 300 divided by 9.81 into A is equal to 300. What is this 300 divided by 9.81? किती येत आहे?
30.58.
Okay, so T minus 30.58a is equal to 300. This is equation number 2. Let's solve equation 1 and 2. Solve equation 1 and 2. Therefore, T is equal to and A is equal to. T किती आला? 40.240 तर 360 आलाय की. इथं लिहिलेलं आहे ते. Here, whatever answers I am having, I will write that answers. Please check. 360 Newton and acceleration is 1.96 meter per second square. These are the answers. Now it is matching answers. Is there any doubt? Doubt आहे का काय याच्यामध्ये कुठलं? Very simple. Just you have to use summation of y. Just you need to draw the free body diagram and see these weights are hang in the air. These weights are hang in the air, so that is why there is no question of frictional force. If those weights are keep on the surface, then you need to consider the frictional force also in the equation. Okay, the frictional force F is equal to mu into R. In the previous numericals, we have considered that. But now this is in air, so there will be no question of frictional force. The next numerical. Determine the tension in the string. Determine the tension in the string. Determine the tension in the string and acceleration of the block. And acceleration of the block A and B. A and B. Weighing 500 Newton. 500 Newton and 1500 Newton connected by inextensible string as shown in figure. As shown in figure. Assume that pulleys are frictionless and weightless. Okay, so determine the tension in the string and acceleration. So the two blocks, so draw the diagram. This string is passing over this pulley and it is attached It is attached in this way. It is passing over this pulley also, and after that, here it is gone like this. Okay. So now weight is attached. Here the weight is attached. And this weight is 500 Newton. And on the other side, here also, weight of this pulley, here the weight is given. So this diagram is given to you. The diagram is given like this only. Is 1500. This is A, and this pulley is attached. Here like this. Okay, so this is the given problem. Now we need to solve it. First, you need to understand that this is 500 Newton pulley. Okay, so this will come down definitely. The direction of motion will be, this is the direction of the motion. This is the direction of the motion, and this will move up. Okay, this will move up. So now what is the difference? See, this pulley, it is connected by two sides by the rope. दोन बाजूनी अशी गेलेली रोप इथनं वरनं येऊन असं गेलेलं. मग हे जर खाली आलं ए नी, if this pulley it is pulled down by, suppose now acceleration A, then this pulley which is on this side, which is having lower weight, it will pull upside by double force, because here two strings are there. So tension in this string will be T and tension in this string will be also T, and both these strings are passed over this pulley. Okay. So what will happen now, if this this two strings and this pulley will come down like this, then this string and this weight will move upward with double velocity and double acceleration. Suppose now the acceleration of moving down is A, acceleration of this pulley is A, then the acceleration of moving up of this pulley is 2A. In these types of pulley system, this is the standard. Okay, so in the industries, these types of pulleys are used, where in the low effort you can get the maximum output. So when this type of pulley system is there, here you can see the string, it is passed over the pulley, and to the other side it is passed over the another pulley. Now on the other side directly it is weight not given, like the previous problem. So this will happen in this type of pulley system. Okay, this is called a chain pulley system. This is widely used in the industry. Acceleration A नी जर खाली आलं ना तर हे 2A नी वर जाईल. हे जर velocity V नी खाली आली तर हे 2V नी वर जाणार. हे जर S एवढ्या डिस्प्लेसमेंट नी खाली आलं तर हे 2S नी वर जाणार. ओके, म्हणजे आतापर्यंत आपण काय बघत होतो की हे जर A एवढ्या acceleration नी खाली आलं तर हे पण A एवढ्या acceleration नीच वर जाणार. If you see the previous problem here, now this is the motion down. If it is come down by acceleration A, it is also moving up by the acceleration A. Here we have considered only A in this equation and in this equation also. Okay, because it is directly passed. हे जेवढं खाली जाईल तेवढं हे वर जाईल. सरळ सरळ करता येते. This is a simple pulley system. This is called as simple pulley system. But this is the complex pulley system. This is called a chain pulley system. So in this system, If this heavier pulley comes down by the acceleration A, it will come down like this. Then the lighter weight pulley will move upward with the acceleration 2A. समजलं? Velocity जर हे v velocity नि खाली आली heavier pulley तर lighter pulley कितीनी वर जाईल 2v डबल नि. हे जर s नि खाली आलं तर हे 2s नि वर जाईल. Okay, this is only the key point in this. So now this is the direction of the motion. So our inertia force will be in opposite direction to the motion. So I will write here, this is the direction of motion. This is the direction of motion. Okay. Now we will show, instead of showing inertia force here, we will show it in the free body diagram. You can show anywhere, no problem. So now here, first of all, I will draw the free body diagram of this 500 Newton block. So free body FBD of 1500 Newton block. So if you draw it, if you draw the block, this is the block. The weight of this is 1500. From this point, weight will act. Okay. Now here you can see the tension in the string. Here is the tension is T. And this string is, the tension is also T. If you consider the free body diagram of this pulley, I will show it. See, I am considering the free body diagram of this much of section. Only about this pulley. This is the free body diagram, what is we are drawing over there of this section. So या सेक्शन मध्ये बघा तुम्हाला काय काय दिसतंय तर ह्याचं वेट आहे 500 करेक्ट. त्यानंतर हे मूव्हिंग डाउनवर्ड चाललेलं आहे आणि इथं पण स्ट्रिंग आहे त्याच्यामध्ये पण टेन्शन टी असणार आहे आणि इथं पण स्ट्रिंग गेलेली आहे आणि ह्याच्यामध्ये पण टेन्शन काय असणार आहे टी. सो टोटल टेन्शन इन द स्ट्रिंग विल बी it is T plus T, it is 2T. So the total tension in the string, this is 2T. Okay. Now here you can see the motion is downward, moving downward. So inertia force will be in upward direction. So this is the direction of inertia force. This is MA because it is having acceleration A. So this is MA. Okay. So now then now solve it. Apply summation Fy equal to 0. What is the weight here? Here it is 1500 Newton. 1500 Newton. Now apply summation Fy equal to 0. Then how it will be? It is 2T minus 1500 plus MA equal to 0. 2T plus M is 1500 divided by 9.81 into A as it is equal to 1500. 2T plus 152.9 A is equal to 1500. This is equation number 1. Please check the values. This is equation number 1. Okay. Similarly, for the second block, this is the weight. Here it is the weight. It is 500 Newton. Tension in the string is T. Then the motion, where is the motion now? Upward or downward? Upward NH motion. 500 Newton motion upward. Motion, then the inertia force will be downward. This is the direction of inertia force. It is M into 2A. Because the acceleration of first block is A, then the acceleration of second block is 2A. So here if I apply summation Fy equal to 0, then it is T minus 500 minus M into 2A is equal to 0. So T minus M is 500 divided by 9.81 into 2A is equal to 500. Right. So what is this equation now? So it will be T minus, with your calculation, 101.93A is equal to 500. Is it right? Yes. So
Yes,
solve
sir.
equation 1 and 2. After solving this, what we will get the value of T and A? What are the values? A is 1.40 and T is 642.85. These are the final answers. Is it right?
Yes, sir.
Okay. So these are the problems on the pulleys. Yes, still we will take one more problem. Take the problem. A pulley of weight 400 Newton has a radius of 0.6 meter. A block of 600 Newton is suspended by a tight rope around the pulley. Around the pulley. The other being attached. The other being attached to the pulley. As shown in figure. Stop. Determine the resulting acceleration and tension in the rope. The diagram is given. This is 600 Newton. Okay, so this is the 600 Newton, and what is the tension? tension will be showing like this. Tension in the string T. Arrow must be away from that. Weight of this pulley is given. W is equal to 400 Newton. And the radius of this pulley is also given. R is equal to 0.6 meter. Now read the problem and try to solve it. At least काय दिलंय काय करायचं हे तरी कळायला पाहिजे. This is the last problem of this unit. तरी किती प्रॉब्लेम झाले या युनिटचे? 5-6 झाले का? झाले किती टोटल? 7-8 पेजेस भरलेत का?
6 प्रॉब्लेम चालू आहे सर.
झाले ना? ठीक आहे, भरपूर झाले. सी प्रॉब्लेम जेवढे करल तेवढं कमीच आहे. तुमच्याकडे असाइनमेंट बुकलेट आहे, त्यात खूप प्रॉब्लेम्स आहेत. Now once you understood this concept, you try to solve the problem by yourself. जिथं अडतंय ना तिथं वहीतला रेफरन्स घ्यायचा प्रयत्न करा, तरी पण आलं तर माझ्याकडे घेऊन या. Okay, but you first show me what you have done, then I will help you to solve that problem. नुसतं ब्लँक अख्खे सगळं असाइनमेंट उचलून आणले तर सगळं त्या सॉल्व्ह करून म्हणलं तर नाही होणार. कळलं काय सांगितलं? You should try first. If it is not get it done by you, then come to. तुम्हाला नाही जमलं तर या माहिती. Okay. So now we need to solve this. So how to solve this problem? See here what they have asked us, determine the resulting acceleration and tension in the root. आता ह्या जो problem आहे, see for this here weight and radius is also given, and now this problem is the rotation about the centroidal axis. Okay. So here what we will do now, we will first consider the free body diagram of 600 Newton block. Okay. आता तुम्ही ते लहानपणी बोरा खेळलात का कधी? बोरा असतं ना त्याला दोरी बांधून फिरता की नाही खाली? बोरा आधी होतो बाबा, आमच्या लहानपणी तर असायचं. तर त्याच्यामध्ये काय टॉर्क, यू विल अंडरस्टँड द कॉन्सेप्ट ऑफ टॉर्क, हाऊ द टॉर्क इज गेटिंग जनरेटेड. व्हॉट यू विल डू, तुम्ही काय करता, ते बोरा घेऊन त्याला असं बाजूला दोरी बांधलेली असते, बांधतो. दोरी पकडून काय करतात, दुसऱ्या एंडनी सोडून देतात त्याला. ज्या वेळेला तुम्ही सोडताय त्यावेळेला काय होतंय तिथं, त्यावेळेला ही दोरी हळूहळू तुमच्याकडे ओढली जाते, आणि ही ज्या वेळेला दोरी अशी ओढली जाते हिला चिटकून, त्यावेळेला हे रोटेशन मध्ये फिरायला चालू होतं. कळलं का? मग हे रोटेशन मध्ये फिरायला चालू झालं म्हणजे ह्याच्यावरती काय आला, टॉर्क जनरेट झाला. टॉर्क जनरेट कशामुळे झाला, तुम्ही जी स्ट्रिंग होती स्ट्रिंग ती तुम्ही पुल केली फोर्सने. Okay, tension will be there in the string. You pull the string by the tension. So tension is there, and whatever the diameter of that काय म्हणतात बोऱ्याचा जो काय सर्क्युलर डायमीटर असेल, त्याची जी काही रेडियस असेल, तर त्या स्ट्रिंगचं आणि त्या रेडियस पासूनचं डिस्टन्स म्हणजे तुमचं रोटेशन कसं मिळणार बघा तुम्हाला. हा बोरा आहे जो तुम्ही फिरवायला लागला, तो फिरवणार आहे तो, आणि ही त्याची स्ट्रिंग आहे. ओके, वन्स यू पुल दी स्ट्रिंग, व्हेन यू पुल दी स्ट्रिंग, ओके पुल केलेलं आहे समजा टी एवढ्या फोर्सने पुल केलेलं आहे, तर ह्याच्या सेंटर पासून याची काय तर रेडियस असणार आहे का नाही, आर. सो द टॉर्क जनरेटेड विल बी इट इज टी इंटू आर, वॉट एव्हर द रेडियस ऑफ दिस लिव्हर आर, अँड बाय द फोर्स विच यू आर अप्लाइंग ऑन दॅट ऑब्जेक्ट, दॅट विल कॉन्ट्रीब्यूट इन टू द टॉर्क. समजलं का? त्याच्याशिवाय ते फिरतच नाही. आर यू गेटिंग माय पॉइंट? तुम्ही रेडियस जेवढी कमी कमी कमी, आता हे पेन आहे, ह्या पेनला जर मी दोरी बांधून फिरवायचा प्रयत्न केला, फिरेल का? नाही फिरणार. का? तर तेवढा टॉर्क ह्याला मिळणार नाही. The whatever necessary torque is there, it will not get by this pen. Why? Because the radius of this pen is so small. If you see the cross section, the radius of this is so small. So this R value is very small. As R value is small, subsequently this value will also be small. So that is why we will not able to generate the sufficient torque to rotate this pen. But if you see, तुम्ही ते जे बोरा फिरवतो त्याचा बघा डायमीटर, ठराविक असा हातात बसायला असं असतं एवढा, बरोबर आहे. काय रिझन आहे त्याला असं ठेवायचं? त्याच्यापेक्षा जास्त मोठा पण केलेला नाही, कमी पण केलेला नाही. द रिझन इज दॅट you should get the sufficient torque, you should get the sufficient radius, and you must be able to apply the force by the means of string. एवढा मोठा जर बोरा केला तर दोरीने फिरवता येईल का तुम्हाला? रेडियस भलेही मोठी आहे, मोठा चेअर एवढ्या साईजचा जर बोरा असला आणि तुम्हाला दोरीने फिरवायचा आहे हाताने बरं का, तर तेवढा मोठा त्याची रेडियस मोठी आहे, ठीक आहे, दिस डायमेन्शन इज लार्ज, बट द टॉर्क यू कॅनॉट अप्लाय ऑन दॅट बिग साइज. म्हणजे तुम्ही फोर्स अप्लाय करू शकत नाही त्याला, फोर्स अप्लाय करून फिरवू शकत नाही. सो दी स्टँडर्ड साइजेस आर डिसाइडेड बेस्ड ऑन दिस. ओके, सो टी इंटू आर जर केलं तर तुम्हाला याच्यामध्ये काय मिळणार आहे? टॉर्क मिळणार आहे. सेम इथं होते, या टेन्शन मुळे जर हे खाली गेलं, हे जर खाली आलं, हे 600 न्यूटनचं वेट जर खाली आलं, तर इथं काय होणार आहे? अबाउट ह्याचा जो सेंट्रॉइडल ऍक्सिस असणार आहे त्याच्या भोवती पुरी गोल गोल फिरणार. ओके, रोटेटिंग अबाउट द सेंट्रॉइडल ऍक्सिस. आणि ते कितीने रोटेट होणार, कितीने रोटेट फिरणार, टॉर्क किती जनरेट होणार? तर जो काही टेन्साइल फोर्स आहे, फोर्स इंटू पुलीची काय असणार आहे? रेडियस. इज इट क्लिअर? सो दॅट कॉन्सेप्ट वी आर गोइंग टू यूज हिअर. दॅट इज वाय पर्पजफुली आय हॅव टेकन द लास्ट प्रॉब्लेम ऑफ दिस टाइप. म्हणजे या टाइपचा सुद्धा एक प्रॉब्लेम तुम्हाला माहित असावा. जनरली these types of problems will not ask in the examination. घेता कशाला म्हणून ह्या टाइपचा जे प्रॉब्लेम आहे हा एक्झाम मध्ये विचारला जात नाही, पण बाय चान्स जर आला तर यू शुड नो हाऊ टू सॉल्व इट. ओके, सो नाउ व्हॉट वी विल डू, वी विल कन्सिडर द free body diagram of 600 Newton block. Okay, everything is same, just pay attention, it is also very easy problem. So free body diagram of 600 Newton block. So now if you draw the free body diagram, this is the block, here is the centroid, then weight is acting vertically downwards, tension will be there, tension in the string. Okay, this is T, this is 600, and this will move down. So this is the direction of the motion. This is the direction of the motion, and inertia force is in the opposite direction to that of motion. Okay. This is the direction of inertia force, MA. Okay. Now if I apply summation Fy equal to 0 here, summation Fy equal to 0, T is moving upward, plus minus 600 plus MA is equal to 0. So T plus M is 600 divided by 9.81 into A is equal to 600. So what is the equation? T plus, what is the value? 61.16. A is equal to 600. This is equation number 1. Okay, this is equation number 1. So you know that what is the relation between normal acceleration and angular acceleration. Okay, here now this pulley will rotate about the centroidal axis with some torque. So now you know the relation, linear acceleration A is equal to R into alpha, where alpha is the angular acceleration. A is equal to R into alpha. Okay, we are talking about the pulley, acceleration of the pulley. I am talking about the acceleration of this pulley now. Okay, so if you consider this pulley, the weight of the pulley is 400, radius is 0.6 meter. So we know the relation, the normal acceleration of pulley is equal to radius into angular acceleration of pulley. So what is the relation between them? So A is equal to radius of the pulley is 0.6. So A is equal to 0.6 into alpha. So the linear acceleration of pulley is 0.6 times the angular acceleration. Okay, so from this, therefore, alpha is equal to, it is A divided by 0.6. This may be required further. Okay, this may be required further. Now what is torque? Now what is torque? Torque is equal to, torque, I have told you, tau is the notation, it is equal to I into alpha. फॉर्म्युला झालाय ना, सांगितलं होतं तुम्हाला. टॉर्क इज इक्वल टू I into alpha. Okay. So here that this torque is calculated as torque is equal to, see here how that torque आत्ताच तुम्हाला सांगितलं, ही पुली रोटेट होणार आहे. पुली रोटेट होणार आहे म्हणजे काय होणार आहे, ही ह्याची रेडियस आहे. दिस इज द रेडियस. This is the radius of the pulley and the tension will be applied from this side. ह्याची जर मोशन डाउनवर्ड झाली, हे जर डाऊन गेलं तर ह्या स्ट्रिंग मुळे ही काय होणार आहे, पुली रोटेट होणार आहे अशी. आणि मग किती टॉर्क जनरेट होणार, तर हे स्ट्रिंग मधलं टेन्शन इनटू रेडियस. ओके, सो इट इज T into R. It is T into R, but R is 0.6. So torque is equal to 0.6 into T. Now I is the mass moment of inertia. Now if you see the pulley is having very less thickness. Pulley normally the thickness of the pulley is very less. So we can consider this pulley as a disc. CD disc असते ना आपली, CD DVD त्याच्यासारखं आपण पकडू शकतो पुलीला, विच इज हॅव्हिंग व्हेरी लेस थिकनेस. तुम्ही सीडी बघितली कधी, त्याची थिकनेस बघा, इट इज नियरली इक्वल टू 0, व्हेरी थिन थिकनेस इज देयर. सो this I is nothing but the mass moment of inertia, and the mass moment of inertia of an object or of a disc which is having very thin thickness, it is calculated as mr square by 2. हा फॉर्म्युला पण दिलाय मी तुम्हाला लिहू, mr square by 2. So here if I put the value, what is the value of m? M is nothing but what is the weight of the pulley? Weight of the pulley is 400. Okay. So weight of the pulley is 400. So it is 400 divided by 9.81 into R is 0.6, 0.6 square, and whole divided by 2. Whole divided by 2. What is the answer? 7.33. So the answer is 7.33. Okay. So the answer is 7.33. Now we will write the equation. Torque is equal to I into alpha. Torque is equal to I into alpha. So here we can see this torque. See, our equation is torque is equal to I into alpha. So this torque value is 0.60. Alena, tau is equal to T into R, 0.60. That value we have taken here. Value of I is 7.33 into alpha. What is alpha? Alpha is equal to A divided by 0.6. That value you should put here. Alpha is equal to A divided by 0.6. Now solve this. You will get the equation. T is equal to 20.38A. This is your equation number 2. Okay. So solve equation 1 and 2. Solve equation 1 and 2. Then you will get the value of A. You will get the value of T. After solving the equation. What is the answer? A किती आलं? 7.3. T is 150. So 7.3 meter per second square, and this is 150. Please cross verify the answers. So this is the problem of rotation about the centroidal axis. आणि हे ओळखायचं कसं? हा सेंट्रॉइडल ऍक्सिसच्या रोटेशनचा प्रॉब्लेम आहे. ज्या न्यूमरिकल मध्ये तुम्हाला पुलीचं वेट दिलं असेल आणि पुलीची रेडियस दिलेली असेल, तो प्रॉब्लेम तुम्ही असं सॉल्व्ह करायचा. ह्याच्या आधीचे सगळे प्रॉब्लेम काढून बघा, एकामध्ये सुद्धा तुम्हाला पुलीचं वेट दिलेलं नाहीये किंवा पुलीचं काय तुम्हाला रेडियस दिलेलं नाही. ओके, तर ते मग मागचे सगळे प्रॉब्लेम ते डी-अलेम्बर्ट्सनी सॉल्व्ह होते. इथं सुद्धा आपण डी-अलेम्बर्ट्स प्रिन्सिपल वापरले. हे काय मी यूज केले ना, दिस इज द इनर्शिया फोर्स, दिस इज बिकॉज ऑफ द डी-अलेम्बर्ट्स प्रिन्सिपल. So this is the normal thing for this block, but while if the weight of the pulley and the radius of pulley is given, then you should use the further approach like this. You have to use this equation, torque is equal to I alpha, and then you need to solve the problem. कारण की इथं तुम्हाला आता इथे एक इक्वेशन मिळालं, इथं जर आता तुम्हाला दुसरं इक्वेशन पाहिजे असेल, एक इक्वेशन आहे आणि दोन अननोन आहेत. किती काय काय अननोन आहे, टी अननोन आहे आणि ए अननोन आहे, आणि इक्वेशन एकच मिळालंय हे सॉल्व्ह केल्यावर. दुसरीकडे इथं वेटच दिलेलं नाही ना तुम्हाला दुसरी फ्री बॉडी डायग्राम द्यायला. आधीच्या प्रॉब्लेम मध्ये दुसरीकडे पण वेट अटॅच असायचं. सो तुम्ही काय करायचं, एकदा ह्याची फ्री बॉडी डायग्राम द्यायचा, एकदा दुसऱ्या ब्लॉकची घ्यायचा, दोन अननोन दोन इक्वेशन सॉल्व्ह व्हायचं. पण आता या केसमध्ये इथं काय, तर इथं फक्त एकच वेट दिले तुम्हाला, दुसरीकडे वेटच अटॅच केलेलं नाहीये कुठं. ओके, आणि ऍडिशनल मग तुम्हाला मग सॉल्व्ह करायला त्यांनी ऍडिशनल माहिती काय दिली आहे, द ऍडिशनल इन्फॉर्मेशन इज दिस इन्फॉर्मेशन, वेट ऑफ द पुली इज गिवन अँड radius is given. So by using that you must generate the second equation. It should be like this, and you have to solve the numerical. Okay, समजलं का?
Yes sir. Yes sir.
Okay, so now with this our this sixth unit is also over. Sixth होता का seventh होता, किती होता? Sixth ना. Section 2 मधला पहिला unit kinematics of particles. Kinematics of particles we have studied. Now this is the second unit, kinetics of the particles. Now the kinetics of the particles is also over. Now the next unit is work, power, energy. Okay, next is work, power, energy. Now work, power, energy, it will require 3 to 4 lectures, 3 to 4 lectures, and after that one more unit is there, mechanical vibrations. It will take only one lecture. Okay, so almost 4 to 5 lectures syllabus is there now. Within 4 to 5 lectures it will be complete. Okay, so now I will upload the MCQs of this kinematics and kinetics. Kinematics I have already uploaded in the teaching diary, MCQs and everything necessary things. Now I will upload this today evening or tomorrow, MCQs of this kinetics of the particle. Okay, you go through the MCQ चॅप्टर तुम्हाला शिकवलाय, एमसीक्यू मधनं जावा, एमसीक्यू चे आन्सर बघा, कुठलं नाही समजलं तर घेऊन या माझ्याकडे. ठीक आहे, सो नाउ वी विल बिगिन विथ द नेक्स्ट युनिट, दॅट इज वर्क, पॉवर, एनर्जी. ओके, 1:55 झाले, संपत आले का लेक्चर? ओके, सो इन द नेक्स्ट लेक्चर वी विल स्टार्ट द वर्क, पॉवर, एनर्जी. Now give the attendance. Roll number 1, 2,
Present sir.
3,
Present sir.
4,
Present sir.
5,
Present sir.
6. Roll number 6, 7,
Present sir.
8, 9,
Present sir.
10, 11. 11 is present. Okay, 12, 13, 14, 15,
Present sir.
16,
Present.
14 is present. 17,
Present sir.
18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25, 26,
Present, sir.
27,
Present, sir.
28,
Present.
29, 30, 31,
Present, sir.
32, 33,
Present, sir.
34, 35,
Present, sir.
36, 37, 38, 38 is present, 39,
Present, sir.
40,
Present.
41,
Present, sir.
42,
Present, sir.
43, 43, 44, 45, 45 is present, 46,
Present, sir.
47,
Present.
48, 49, 50,
Present, sir.
51, 52, 53,
Present, sir.
54,
Present, sir.
55, 55, 56,
Present, sir.
57, 58, 59, 59 is present. Okay, 60, 61, 3, 4, 5, 6, 7, 8, 9, 10, 10. Is there anybody who is present? 57 is present.
44 is present, sir.
44 is also present. Okay. Anybody? You can see the roll numbers on your screen. Those which I have written, those are absent numbers. If anybody is present, let me know. Eight students are absent. Okay.